right here, and you can see where we've created a variable called I, and we've given it a value of 0. So a loop is basically what we use anytime that we want to do a repetitive task inside of a program. So in this case, we're creating 50 boxes. We don't want to have to type out 50 times, create a new box, so we make a little loop. In this case, every time that this loop happens, I is going to get incremented by 1. You see right here where we've said I++? That's just kind of a shorthand for saying add 1 to the value of I. We could also do it kind of like this. We could say I plus equals 1, but it's a couple more characters. It's easy just to say I++, and that's very common. That's usually how it's done in these types of loops. So the first thing that we're doing is, we're going to loop through and make all of our 50 boxes. But what we want to do, because we are actually going to run 3 different loops on these boxes, we need a way of telling Flash, well, remember these boxes, don't just make them. That means we need to put them inside of a data collection. Now, the one data collection, well, there's 2, but the most used data collection inside of Flash is the array, and that's common to a lot of programming languages. So you can see right here where we have our array, we're making our new array inside of line 26 here, and each time we cycle through and make a new box, we put it inside of the array using the push function. And we've talked about arrays and the push method for the last couple of classes, and hopefully by now you're getting fairly familiar with that. So at the end of this method here, at the end of the build method, we are going to be left with an array that has 50 boxes in it. But at this point, they're not going to be visible on stage, nor are their properties going to be any different. So those are our 2 other responsibilities that we want to create. And to do that, we've got 2 more methods created. One is called allocate, and one is called show. And as you can see from the comments here, line 35 and line 51, those 2 other responsibilities are exactly what these methods do for us. So the allocate function, it's going to be able to, once again, loop through all of those boxes and set properties on them. And the reason why it can do that is because the boxes are all being remembered inside of that array. So notice here where we're, once again, creating our for loop, right? And now here's something to take note of, because previously we were just pushing items into the array. See that right here? And as we know, every time we push another item into the array, it adds to the length of the array. So at the end of it all, we're going to have 50 boxes inside of the array. But when we're actually retrieving items back from the array, we need what is called an access operator, which is this little square that we see right here. See how our variable is inside of opening and closing square brackets? So we did a little demo in class where we were talking about access operators before, and they basically have one simple job. Whatever you hand them inside of there, they will go into the array and fetch that piece of data. It's kind of like, they are the kind of the doormen. They're authorized to go into the club looking for somebody who has that particular ID. So in this case, the ID is number, and that's good because, as we know, items that are stored inside of an array are stored there numerically. So as this loop happens, these guys are going to just keep going on into the party and saying, hey, give me the box that has the ID of number 1. Give me the box that has the ID of number 2, and so forth. Now the important thing to remember is that when these guys fetch something from the array, they don't remove it out of the array. They just say, hey man, what's your box? Okay, cool, we'll do stuff with that box. So the item is actually left inside the array when we access it using the access modifiers. If we pull it out using a method like, say, pop or slice, then it's actually removed from the array. So the length of the array actually gets smaller each time that we do that. But in this case, we're leaving it in there. And the reason why we are leaving all of the boxes in the array is that we've got that third function, which is called show. Now the show method has just the responsibility of adding all of the boxes to the stage using the add child command. Now in the next class we're going to talk a little bit more about the display list and add child, but for now just need to know that anytime you do an add child, it takes the item that you are adding and makes it visible on the stage. There's more to it, but we're going to get to that. So that kind of covers our three methods that we created, and there was just one more point that we were talking about, which had to do kind of with scope. So recall that we spoke about how each of these methods here are kind of like a party, and inside the party there's a bunch of stuff going on that is specific to each party. Now you will notice that down inside of allocate here, and also even inside of build, we've made a mention to my array of boxes. And if we look for where my array of boxes is declared, and when I say declared, we're talking about like the very first time that we mention my array of boxes, you can see that it's way up here in line 11. It is inside the class. See that? Here's the class and here's the opening brace for the class. So it's inside the class, but it's not inside of any of these methods at all. That's pretty interesting. What that means is that in this case, my array of boxes, this array, is kind of standing in the alley outside of these clubs. And he has access then to, so any of the items inside of the club here can quickly look outside into the alley and they will actually see my array of boxes. Now that's important, because if my array of boxes would have been declared down here inside of the build function, let's actually see what that would look like right now. We could do something like this. Right? We could do it something like that and then just, you know, get rid of this. And if we did that, the build function would still work. But we would run into a problem. Let's just comment this one out here so it's not confusing us. We would run into a problem when the second function was to execute, because what it would do is it would look inside, you know, the party would be going on in here, each of these lines are executing, and in line 40 it makes a reference to my array of boxes. Well, anytime that we make a reference to a variable like that, what Flash does is it looks for it right inside of the function here. So inside the club it looks around and says, hey, is this guy here? Oh, he's not here. Where's the next place it looks? Well, it looks out in the alley. It looks in this area up in here that is outside of all the clubs. But see what we've done here. We've now created the declaration of the array and the instance inside of one of the clubs, which means that, you know, when they go to look for them in this club, they don't find them, and then they look outside in the alley, they're not going to find them there either, and Flash is going to bonk out. It's going to run into a problem. So to fix that, any variable that we think we want to be able to be available inside of any of the clubs here, inside of any of the functions, we just have to declare it out in the alley. So let's fix this thing up here. I'm going to Control Z my way back out of what I did.